This is question 18 from the first CSAT sample paper. In this question we're told we're standing on the Earth, we go n miles south, then n miles east, then n miles north, where n is some amount less than the radius of the Earth in miles. And we end up back where we started, but we haven't visited any point more than twice. So we're asked, how close to the South Pole can we start in order to do this? So if you want to have a go at this question yourself, pause the video now. Okay, so first things first, it's worth noting that we could start at the North Pole. The North Pole would be a solution, because from the North Pole, whatever direction we set off in, we're going south, and then we can go east. We can go south any number of miles we want, then we can go east the same number of miles, and then if we go north the same number of miles again, we're going to end up back at the North Pole always, no matter which direction we went in when we first left the North Pole. So that's always going to be a solution, but we're asked how close to the South Pole could we start, and the North Pole is as far away as you can get. So we want to try getting closer than that. The problem with starting anywhere other than the North Pole is, if we start at any point, we can only go, there's only one line that goes north or south through that point. So if we want to get back to here, having gone south and then east and then north, that means we have to retrace this line, because this is the only line that goes north or south to that point. But it's okay, because we're told we don't visit any point more than twice, so that means we can visit points twice. So I've drawn this as two parallel lines, but this is meant to be one line which we're going along in two directions. So we can go down, and then we can go all the way around the Earth, and then come back up. And we'll return to the same point. And we've gone along every point on this line twice, but we haven't gone along any point more than twice. It's worth noting we couldn't go down and go round 2 times then come back up, because then this point here we'd have visited 3 times, which isn't allowed. And if we start from here and do this, then obviously we're closer to the South Pole than we were when we started at the North Pole. So it's worth trying to figure out if we can do this, and if so, how far from the South Pole are we starting? So I've drawn on here the equator. I'm going to try and start below the equator, and I'll justify that later. But let's try and start below the equator. And let's think about what these distances are. So I think in this case it's easiest to imagine taking a slice through the North and South Poles and through what are called X and Y. So X is where we start, Y is where we start going east. We'll take a slice through the Earth and look at it from the side. So if E's on the equator, I'm trying to start at X, go to Y, and then do a loop like this, get back to Y and go up to X again. And I'm looking at the angles here between the radii to these points, because we're looking effectively now at distances along a circle. So as long as we work in terms of radians, it's easiest to think about angles, as we'll discuss in a second. So from the angles I've written here, we can write down the distance xy and the distance x to s. Bear in mind, x to s is going to be what we're trying to find, because that's the distance from the South Pole when we start. But to get the distance we go around in a circle when we go east, we're going to have to know, we're basically doing the circumference of a circle with this distance from y to this vertical line as the radius, so we have to work out that distance. So to do that, I've drawn another triangle. Here alpha is just beta plus gamma. And if I draw a horizontal here and here, these two angles are the same, these are both alpha. This diagonal here is the radius of the Earth, and therefore this here is r cos alpha. And so this distance is going to be 2 pi times r cos alpha. So using that, now let's try and work out the distance xs. Okay, so xs is what we're trying to find. And we'll start by noting that alpha here is beta plus gamma, because what we're going to use is, just in case you haven't seen this before, if I have a circle and I've got an angle theta at the centre, radius r, what's this distance, the arc length? that distance is just theta times r if we're working in radians. So alpha is beta plus gamma, and xs, what's that going to be? Here, the radius r is what they call big R, and if we look at distance xs, the angle here, the angle between this vertical and this horizontal to the equator is pi by 2, and the angle between x and s is pi by 2 minus beta. So the distance is r times pi by 2 minus beta, using this rule. And n is the number of miles we go. Well, that means it's the distance xy, so that's gamma times r, using this rule. And it's also the distance we go around the Earth, which we already said is 2 pi times r cos alpha. So these two are equal, and they're both equal to n. So that means we can find alpha and gamma in terms of n. So gamma is going to just be n over r from this equation. And alpha, from this equation we get cos of alpha is n over 2 pi r, and then we say alpha is arc cos of that. So I've written a note here. This only works if alpha is acute, because arc cos is limited to between minus pi by 2 and pi by 2. So alpha wouldn't be acute if we started above the equator. So in a second I'll discuss why we can start below the equator, and that means alpha is going to be acute. So we'll justify this step in a second. Before we do that, I wrote xs in terms of beta, and using this we can find beta in terms of alpha and gamma. So we just get beta is alpha minus gamma, so it's arc cos n over 2 pi r minus n over r. So what is xs? Well, we'll figure that out on the next page. Okay, so I've written out a derivation for distance xs, which is what we're trying to find. So we already had this information. Xs is r times pi by 2 minus beta, and beta was this angle, arc cos n over 2 pi r minus n over r. So we can just plug this in here. We get r times pi by 2 minus arc cos n over 2 pi r plus n over r. And now the thing to notice is if you have pi by 2 minus arc cos, I've drawn a triangle here to show what happens. This actually becomes arc sine, because suppose this is my arc cos. So suppose I call this theta, and I'll call the hypotenuse 1 just to keep things simple. This is x, so I've got cos of theta as x. Then this angle at the top of the triangle, because it's a right angle triangle, is pi by 2 minus theta. And that means sine of this angle is going to be x. So theta is arc cos x, then pi by 2 minus theta is arc sine x, as long as everything's acute, which we're going to justify in a second. So that means this part becomes arc sine of n over 2 pi r. We could have gone straight there if we'd drawn the picture slightly differently. So we could use sine instead of cos. And this is n over r, and because I've got this r outside, I can multiply through, so I just get n plus r times arc sine of n over 2 pi r. And because this is going to be acute, because we're expecting this to be acute, we're getting something positive here. So we've got n plus something positive, which makes sense in context, right? Because we can't go n miles and then, this is distance to the South Pole, remember? We can't go n miles and then get to the South Pole, because then we couldn't go east, because we'd be stuck at the South Pole. So it makes sense we've got n plus something positive, because we're n miles from the South Pole at least, and then something else. So this is our final answer. But now I'll just go and justify my assumption that the point x was below the equator, and so all the angles are acute, which I've been using all the way through. Okay, so here's my formula again, and we're just going to check all the angles are acute, or that x is below the equator. So I've got my picture again of my slice through the Earth. This is what I'm assuming happens. Remember, beta plus gamma is alpha. So what do I want to happen? I want this value here, which is xs, to be less than a quarter of a circle, which is just pi by 2 times the radius, pi by 2r, or es, as I've drawn it on the diagram. So that's what I want to show this is less than. So I'm going to have to think about the size of this first. So I'm going to start with n over 2 pi r, and all we know is that n is less than r, it says that in the question, so this is less than 1 over 2 pi. We've got to figure out what happens to arc sine of this. So in order to do that, I think it's easiest to compare. We basically want to compare arc sine of x with x, or some multiple of x. So what I've drawn is sine of x, and then if we draw the straight line y equals 2 pi times x, because sine reaches 1 at pi by 2, I've introduced 2 over pi times x, so that the straight line meets the curve again at x equals pi by 2. So that means it's below it for all these acute angles here. So that means for acute angles, sine of x is bigger than 2 over pi times x. I could have chosen another smaller number, but this is enough. And this is also nice because these things are both over pi. So that means that x is going to be greater than arc sine of 2 over pi times x, because arc sine is an increasing function. So I get this out, and now I can do arc sine of this. So arc sine of this part is less than arc sine of this, because again arc sine is increasing. And what is x in this case? X here is a quarter, because then I get 2 times a quarter over pi is 1 over 2 pi. So that means this arc sine is less than a quarter. So that means this here is less than a quarter. So now I want to think about this whole expression. The left-hand side is just the distance xs, and n we know is less than r. We know this here is less than a quarter, so that means the whole thing is less than r times 1 plus a quarter, which is 5 quarters. And we want to show it's less than pi by 2 times r, and that's fine because pi by 2 is bigger than 3 halves, which is bigger than 5 quarters. So this is less than pi by 2r, so that means it's less than es, which is the distance from the equator to the south pole, or a quarter of the circle. And that means that x is going to be below the equator and all the angles are going to be acute. So we get exactly what I was assuming all the way through. But I think it would have been fine to just use your intuition and assume this is possible, provided n is less than r, because they probably gave you that inequality to make the question easier. So it makes sense that you'll be able to pick a point below the equator, which simplifies all your equations.